AMD Developer Inside Track is here with Chip Freitag from the ACML team. Chip, why don't you introduce yourself?
I'm Chip Freitag. I currently am a project engineer for the AMD Core Math Library. I've been with AMD 17 years. I started back in the 29K days, and I've been a marketing engineer and a software developer for much of that time.
Wow, another 17-year veteran. That's awesome. So, as you mentioned, the AMD Core Math Library is the team you're managing now, and I'm just curious, can you tell the audience what is ACML?
ACML is a collection of optimized math library routines, typically used for scientific and high-performance computing. It consists of the BLAS, the basic linear algebra subprograms, the LAPACK, a collection of FFTs, random number generators, and a small collection of optimized math transcendental functions.
Great. And who should be interested in this? Who are your main users?
The user, anybody with an AMD computer who's doing any kind of scientific or high performance computing programming would be interested in ACML. If you're developing applications such as finite element analysis, or for oil and gas, or aerodynamics, or crash simulation, those types of applications, you're probably calling functions that ACML has optimized for AMD platforms.
Right, so very high computationally intensive programs, it sounds like.
That's right.
So I'm also wondering, I found that we have an ACML-GPU version of ACML. Can you tell us some differences? What are
Sure. ACML-GPU is an offshoot of ACML. It's a separate download. It includes all of the same functions that are in ACML, and we've optimized key ones of those functions for operation on the GPU. Specifically, we've optimized SGEM and DGEM. We're coming out with a new version soon that will include ZGEM and CGEM. Since those are the key drivers of performance for many of the other functions in ACML, for certain applications, many other functions in ACML will be able to take advantage of these optimized GPU functions.
Okay, and what sort of hardware would they need if
currently we support ACML-GPU is only supporting ATI graphics cards. Okay. You'll get the best performance when you're running with a higher end graphics card, such as a 4870 or the new generation, the 5870 cards. It also runs on other ATI GPUs as well.
Okay, and how about the regular ACML? Does that only work on AMD processors?
The regular ACML runs on AMD processors. It also runs very well on non-AMD processors. We've taken steps to ensure that we've done optimization for other processors as well. So you should give it a try even if you don't have AMD processors.
So it's safe to say that ACML is a cross-compatible platform and actually even cross-optimized platform.
Yes, and in fact we get a lot of feedback from our customers that that's a feature that they like to take advantage of.
That's always good to know, because I know a lot of developers have a hard time, do they do one optimization path for AMD only, or do they have to do two if they want to also optimize for non-AMD? But in this case, they can use ACML and it will run well on both.
That's platforms. Right, and we've made those decisions inside the library so that when it detects that it's running on an AMD processor, it'll run the AMD kernels, and then in other instances it'll choose more appropriate kernels.
Good to know. So for someone getting started with ACML, what sort of resources are available?
So starting when you download the package, you'll see in addition to the help in the help files in the user guide that are included with the package, we have a set of examples that we include, and these are fairly simple examples of how to call various functions within AMD, within ACML, and how to compile your application to take advantage of ACML, and how to link ACML with your application. We provide support for a variety of compilers, including G-Fortran, PGI, Open64, and the Intel iFort compiler, in addition to Microsoft Visual Studio. Other help resources include our online resources, including our ACML forums on Dev Central. We have a collection of knowledge base articles. We have an online user guide, and we also have an email support link on Dev Central, and we get those emails directly when you submit those email help requests.
That's great. So can you tell me what's the development team working on now, and what's coming up down the line?
We just released ACML 4.4 in late February, and since then we've shifted focus to start working on the next generation of AMD processors. We're heads down developing the assembly kernels to support the next generation processors. We'll be working on that for the balance of the year, and we'll have a beta release towards the end of the year. In addition, we'll be adding some other features such as LAPAC 3.2 and some enhancements to the calling interfaces for FFTs, including 2D and 3D real-to-complex FFTs, with some new storage formats for real-to-complex FFTs.
Excellent. Well, thanks so much for your time, Chip. This has been really helpful for my understanding of ACML, and hopefully helpful for our developer audience as well.
Sure.